Hello everyone, and welcome. Today I'll be presenting on an important topic in pharmacology, the metabolism and toxicity of acetaminophen. Let's get started. Acetaminophen, paracetamol, is considered one of the safest and most commonly used over-the-counter pain relievers and fever reducers when taken at recommended doses. It is generally well tolerated, does not irritate the stomach lining like NSAIDs, like ibuprofen or aspirin, and is safe for most people, including children and those with cardiovascular or gastrointestinal issues. However, while it is safe at therapeutic doses, acetaminophen can cause serious liver toxicity if taken in excessive amounts or combined with alcohol or other liver-stressing substances. Even slightly exceeding the recommended dose over several days, chronic overuse, can lead to liver damage. Therefore, it's important to follow dosing guidelines carefully, such as no more than 4 grams per day for adults, and to avoid combining multiple medications that contain acetaminophen. Prior to discussing the molecular mechanism of its toxicity, let's examine how the metabolic process of acetaminophen looks like. Normally, acetaminophen is primarily metabolized in the liver through glucuronidation and sulfation pathways. A small fraction is metabolized by the cytochrome P450 enzyme system, mainly CYP2E1, into a toxic intermediate, N-acetylparabenzoquinone, NAPQI. In therapeutic doses, NAPQI is rapidly detoxified by glutathione and safely excreted. However, in overdose situations, glutathione stores become depleted, allowing NAPQI to accumulate and bind to liver cell proteins, leading to hepatocellular injury and potentially acute liver failure. Furthermore, as we highlighted in the introduction, acetaminophen toxicity is more easily triggered in individuals who consume alcohol, and this occurs through several interconnected mechanisms. Let's see how. Ethanol induces the liver enzyme CYP2E1, which is responsible for converting a portion of acetaminophen into its toxic metabolite, NAPQI. In people who consume alcohol chronically, CYP2E1 activity is increased, leading to greater production of NAPQI, even at lower doses of acetaminophen. Furthermore, chronic alcohol abusers often have pre-existing liver damage, such as fatty liver, alcoholic hepatitis, or cirrhosis, which compromises their liver's ability to metabolize drugs safely. This impaired liver function makes them less tolerant to injury from acetaminophen, even at therapeutic doses. The primary treatment is N-acetylcysteine, NECI, which replenishes glutathione levels and enhances the detoxification of NAPQI. N-acetylcysteine is most effective when given within 8 to 10 hours of ingestion, but can still provide benefit even if administered later. Early recognition and prompt treatment are critical for reducing liver damage and improving outcomes. In summary, understanding the metabolism and toxicity of acetaminophen is essential for safe clinical use and effective patient care. Finally, I appreciate you joining me on this journey. Stay curious, keep learning, and thank you for watching. And don't forget to like, share, and subscribe the channel. See you.